Okay, let's do the last question for test 1.3 for me. Question number 3, Roman number 1. Okay, so they're asking which of these is rational and irrational. So first of all, let me tell you what is rational and irrational. Okay, before we start this, let's go to natural numbers. Natural numbers are numbers which start from 1, 2, 3 and infinity. Whole numbers are numbers which start from 1, 0, 1, 2, 3, infinite. Integers includes negatives, 1, 0, 1, 2 and so on. And then fractions are fractions, right? So next comes rational numbers. Rational numbers are all these numbers included plus all the numbers lying between any two integers. For example, this and this, -1 and 0 la majority number ke mana so rational number. For example, -0.1, -0.3, all these are rational numbers. Any number lying between any two, between 1 and 2 also. There's 1 point, you can write long 1 also, 99999. Everything is a rational number. Okay, even numbers like, for example, in this case 1.999 dot 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 9 repeat korna, which means 1.9 bar. Even this is a rational number. So all the numbers that you have learned so far from your lower grades till now, everything is rational. Okay, everything is rational numbers. So the main question is, if everything is rational, what is irrational? So irrationals are non-terminating and non-repeating. This means what? See, this is non-terminating, okay, this kind of numbers, but this is repeating. 9 is being repeated again and again and again. For example, this one, or 1.3333 dot 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 dot, which means 3 is being repeated again and again. So even this is a rational number. And this one, I can write it as 4 by 3. Why? Because if I divide, 3 ones are 3. See, if I divide 4 by 3, 3 ones are 3. 1 in hand, you put a point, 0 to the 9. 1 in hand, 0 to the 9. Right, 1 in hand, 0 to the 9, and it'll also go, it'll go on, right? So 4 by 3 literally is 1.3 bar. So even this is a rational number, okay, because this is repeating. So irrational numbers are non-terminating, just like this, but it has to be non-repeating. Best example, 0.1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 3, 4, 5, dot, 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 dot. It has a pattern, but then nothing is repeating. If I ask you to put a bar on top of this, you will not be able to put a bar, right? So this is irrational number, and irrational numbers can never be written in the form p by q. So if you divide something by something, okay, divide anything by something, it will always result in a rational number. That's the main concept, because irrational numbers can never be like, you can never get an irrational number by dividing something divided by something korna kita be irrational number na pao, which is na. So irrational number usually we get it by finding the square root of prime numbers. So square root of 7 is an irrational number. Square root of 3 is also an irrational. Square root of 2 is an irrational number. So when you divide these things, the numbers will always go on and on and on, but nothing will repeat ever. One of the most irrational number is pi. Even pi value is irrational. The numbers goes on and on, but nothing repeats. Okay. So that's the whole concept of irrational and rational. Okay. So this is one of the so here, see, they did not put dot 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 dot, which means this is terminating. If it's terminating, it is a rational number, right? If it's rational number, they're asking what it would point as well. So this means, since point is it means something is dividing this. Every rational number can be written as p by q form, like I told you. Something divided by q or not, pi jawa parina, rational number. So if this is written in the p by q form, what can you say about the q they're asking, the denominator? So we can say, since it is terminating, okay, like you studied in question number 1 and 2, since it's terminating, the denominator will be of the form 2m into 5 to the power n. Mon terminating kuri namte itu takili terminate kuri na kuri kisho na. So whenever we, like in the previous question, whenever we prime factorize and there was only 2 or only 5 or 2 into 5, we said it is terminating. So since it's terminating, we know that the denominator would be of this form. Got it? For this one, clearly it's irrational number because 1, 2, 0, 1. If I ask you to put a bar here, you cannot put a bar, right? Pattern is there and it's increasing and going, but there's dot dot also non-terminating, like it's never ending and non-repeating, so irrational. So we don't have to say anything about that. That's done. For this one, I told you this is non-terminating but repeating, so it will be a rational number, and this number can also be represented in P by Q form. Okay, so what can we say about the Q? We can say, since it's repeating, since it's non-terminating, we can say the denominator is not of the form the 5n, right? Because it's non-terminating, we can say it is not of the form this, because if it is of the form this, it would have terminated, right? So that's it. That's number 1, 2 and 3. So what I've done is I've made some questions, okay, multiple choice based on this chapter. So this is all this is based on the 1.2. So write your questions and try it. So there's 4 questions here. There is 3 more questions here. So let me start from question number 1. Okay. So let's read the question. If HCF of this is 4, LCM of this and this is, oh wait, wait, okay, okay, it's write 24, okay. So HCF is 8, LCM is 24. So we know LCM into HCF equal the product of the two numbers. Yes. So LCM to 24, HCF to 4 into 8, 8 1 is 8, into 24, 4 to 12 is correct answer. So that's it. So let's try number 2. For number 2, LCM and HCF of two numbers is this and this, the product of the two numbers. Same. LCM into HCF equal to product of two numbers, na? So LCM to into 4. 6 4 to 24. See, this is a shortcut, okay? Like how to calculate. 6 into 4 is 24. So it's ending on 4 when I multiply these two. So I can guaranteed say that this is the one because the array is not ending on 4. Got it? Like only 4 theta like it like what it was. 6 4 24, 9 6 9 4 36 and 38. You know, you have to do and go if there's more force. Okay. Anyway, from this question number 3. So what is if the HCF of 63? I do a question. This also I excuse me. So you have to write this. If the HCF of 65 and 117 is in the form of 65m minus 117, then the value of m is so HCF of 65 and 117. See, I don't see the one number which can divide. See, I know 65 is divided by divisible by 5, but you don't know enough. So, but just try dividing by 5 once. What you'll get? You will get 13, right? 13 into 5. So try dividing this by 13. So 13 into 9 into 117 also. So which means 13. Which number is 9? Even if you don't know tables of 13, this is how you know. 1, 2, 9. So HCF is 13 because these two we cannot divide anymore. So HCF is 13. So they are saying HCF is in the form of this. So 6m 65 m minus 117 equal to 13. So 65 m equal to HCF now. This in HCF of this and this is in the form of this. So this number. So 117 goes this side. 13 plus 117, 130 by 65, 2. So it should be 2. Okay. Let's do 4. If the positive integers a and b are written, so we have ab square b equal to a square b. Okay, for the timing, I'm just going to write this as a into b into b. Here I'm going to write this as a into b. So what is the HCF? HCF means the common one, right? So what is LCM? LCM is write the HCF first and then write the remaining. So b into a. So a into a is a square, b into b is b square. So this is the LCM, okay? But this is like I'm showing you the proper way to find out. But there is a shortcut method for this question also. The shortcut method is if they are giving it in factorized form like this, okay, then the LCM will always be the highest power. Highest power. So the highest power of a in this case is a square, b in this case is b square. So if they already like a equal to 2, 7 into 3, 8 into 5, 5 yeah, this is number. B equal to 2, 5 into 3, 7 into 5 to the power 8 this. So LCM will be, they give just like this, the LCM will be 2 to the power 7 because is the highest one, into 3 to the power 8 because 8 is the highest of 3, into 5 to the power 8. You know which number? The highest of 2 is 2 to the power 7, so you write 2 to the power 7 into 3 to the power 8 into 5 to the power 8. The same goes for ABCD as well. A squared b cubed c to the power 4, a4 b cubed c to the power square. LCM will be the highest power of a, a4, highest power of b, b cubed, highest power of c, c4. This will be the LCM. So don't forget that it's a shortcut. Otherwise, you can, if you have doubt, you can do it like this, like manually. You'll get the same answer. Okay. Number 5. So now that was LCM. Now it's HCF. So HCF, I'll show you the proper way, and then I'll show you the shortcut. Okay. R 1 2 3 4. B 1 2 3 4. 1 2 3 1 2 na 1 2 1 2 3 1 2. So P into P into Q into Q into Q into R into R. So P square Q cube R square is the correct answer. So this is the manual way. So what is the shortcut? Shortcut LCM was highest, right? HCF, you take the lowest power. So for example, in this question, the lowest power of P is P square. The lowest power of Q, it's same, exactly the same. So lowest power of R is R square. So that's it. So even if you change it into numbers or whatever, it's always be the lowest power for HCF and highest power for LCM. Okay. Now let's do the next question. Question number 6. 11 wants to stack 420 Hindi books and 130 Sanskrit books, such that each stack have the same number of Hindi and Sanskrit books. What is the maximum number of stacks that she can make? So the question is saying the librarian has 420 Hindi books and then 130 Sanskrit books. So what she wants to do is she wants to make stacks, books of like in such a way that each stack has equal number of Hindi books each stack, which means if this stack has 7 Hindi books, every stack should have 7 Hindi books. Got it? And then each stack has equal number of Sanskrit books. excuse me, Sanskrit books. Which means if each stack has 3 Sanskrit books, every stack should have 3 Sanskrit books. So that's the question. So they're saying, what is the maximum number of stacks you can make if you want to have equal number of Hindi and equal number of Sanskrit in each stack? Okay. So if you try and understand this question they're literally saying, see, to have the maximum number of stacks, which means the highest number which is common for everything, for both of them. That's what they're saying, right? The highest number which is common for both of them, which means HCF, right? I'll tell you why it's HCF properly again. Wait. HCF of the two. 14T 130, let's divide by 5. 5 8s are 5 4s are 20, 5 2s are 5 6, 2 4s are 2s, 2 3s, 13 into 4 is 52. So we cannot, so HCF is 5 into 2, that is 10. So HCF is 10, right? So see, HCF 10 means the highest number which can divide this and this as well is 10. So 14T divided by 10, 13 by 10. So 42, 13 by as well. So each stack should have 42 Hindi books and then 13 Sanskrit books. That's what it literally means. That's why we're trying to find HCF. Got it? So HCF is 10 means there will be 10 stacks. Every stack will have 43 Hindi books and 13 Sanskrit books. That way, in 10 stacks, and all the 10 stacks will be equal. Got it? That's what it means. Last question. So this is a very similar question to what we already did, like in 1.4. So see, let's say 4 7. So the interval. So whenever there's an interval, so every 4 minutes. So just think of it in a round way. So every 4 minutes, the bell rings. So 4 minute take tomorrow, next 8 tomorrow, next 12 tomorrow, 16 tomorrow. It will go on. For 7, it'll be 7 minutes, 14 minutes, 21 minutes, 28 minutes. It'll go on, and then for 14, 28, 30, 52. No, 42. Yeah, 42 and so on. So this is basically the 14 table, 7 table, 4 table, and they're saying when will they ring together, so you have to find the LCM. So if we try to find the LCM of 4, 7 and 14, we do it by 7. 7 1s are 7, 7 2 2s are 4, 2 1s are, so we cannot do the 2 2s are 4, 7 for sure, 28. So LCM is 28, which means if they rang at 6 AM first, the next time they'll ring together is 6:28. Okay, next class I will be providing MCQ for exercise 1.5.